Today we're going to look at mass engineered timber, and amongst the different types of mass engineered timber, we are going to focus on the cross-laminated timber and glue-laminated timber. So cross-laminated timber, we give them a short form, we call it CLT. Glue-laminated timber, we call it glulam. As you can see from this diagram, mass engineered timber is not solely restricted to CLT and glulam. There are different types of timber materials that can be produced from the logs after you decide to go for sawing or peeling or stranding. But for today, we are going to focus more of our attention onto glulam and CLT. One of the questions that we always ask ourselves is, why do we want to use mass engineered timber when we can use concrete or we can use steel? Well, there are some advantages of timber over steel and concrete, just like there are also some disadvantages. In terms of advantage, the timber is versatile, lightweight and easy to fabricate to the required shape and size. You can look at a video on how easy it is to fabricate the timber into the structural components. That is not so easy to do when you are handling concrete and steel, simply because they are not easy to cut, but timber is relatively easy to cut. The other advantage is the ratio of the strength to the density. If you compare timber, concrete and steel, it is correct to say that timber has a low strength compared to concrete and steel. But the advantage of timber is that the density is actually lightest or lowest compared to concrete and steel, and it is very much lighter. So as a result, the ratio of the strength over the density then becomes bigger than the concrete and the steel, and that actually provides some form of advantage. The other reason why we want to consider using mass engineered timber is that the timber components typically offers less thermal conductivity. It is 10% of concrete and 0.5% of steel. So when we use timber components, we don't need to spend so much energy on the cooling load. Another good reason is because it is a renewable resources. It can be recycled. Remember the wood chips that we talked about in the earlier weeks? Okay, it can be reused. And the biggest advantage is that it is quick to produce, meaning that the components is quick to be produced in a factory to a high quality standard. In terms of the work using the mass engineered timber on site, typically is a series of assembly works. The components are fabricated in the factory off-site, transported to the site, and on-site we assemble the timber components. And these are the tools that we use for assembly of the timber components. They are relatively easier to handle compared to the very heavy type of tools that we need in order to connect concrete components or steel components. So that is another advantage, quick to install. In terms of fire safety requirements, STDF in Singapore has allowed the designers and the builders to use mass engineered timber as a structural material. Just like for concrete and steel buildings, mass engineered timber buildings must comply with local fire safety requirements. For example, height limit. Generally, there is no habitable height limit for mass engineered timber buildings, except for healthcare occupancy, where the height shall not exceed 12 meters. And one of the reasons for this restriction is for healthcare occupancy, if there is going to be a fire incident, it will take a longer time for the patients to be evacuated. So that's why the authorities do not want the building to be too high. So 12 meters is probably around three stories, that sort of thing. The fire safety performance-based approach shall be adopted in the design where the habitable height is greater than 12 meters. And in terms of sprinkler system, automated sprinkler system can be exempted if the habitable height is less than 12 meters, no healthcare occupancy, and there is provision of alternative fire protection measures. For example, fully encapsulated timber elements are provided and protected by automatic fire alarm system. The escape provisions such as staircase and lift shaft, you can construct using the mass engineered timber if it is protected by fire rated boards and the habitable height is less than 12 meters, no healthcare occupancy, and is not used as a staircase shelter. From the infographics on building with mass engineered timber, you can see that this is the building processes. The manufacturers will harvest the wood from sustainably managed forests, and then layers of timber panels, they are glued together for strength and structural stability, cut to exact dimensions with computer-controlled machineries in factories. Then the timber components, they are delivered to site and easily assembled without the need for wet works. So in terms of benefits, you can have production gains where savings up to 35% of manpower on site can be achieved. You can then apply the concept of design for manufacturing and assembly to reduce the construction time. So we have mentioned just now that timber has a high strength to weight ratio, makes it easier to handle compared to the heavy steel and the heavy concrete. And of course, it is environmentally friendly. Highly renewable, sustainable construction material with long service life, significant reduction in energy usage and carbon emission during the manufacturing and the construction process compared to that for the steel and the concrete. It provides a higher thermal comfort, reduced heating and cooling loads for the building occupants. There will be less waste due to the precise manufacturing in the factory. There will be less noise, less dust generated, and it can reduce up to 70% the concrete usage in the building. And on top of it, you also have a safer working environment because the loads on site will not be as heavy compared to steel and concrete. PCA is taking the lead to drive the industry and encourage the industry to consider using mass engineered timber as a structural material. So initially they built a simple building on top of their academic tower block to showcase that you can use mass engineered timber to construct timber structures. And that building is the PCA Skylab Visitor Gallery. So it's quite a small place. The amount of this mass engineered timber is not a lot, but it's to showcase to the industry professionals that we can consider using this as an alternative material to concrete and steel. So for this project, there is about 50% manpower savings, and the benefit is that speed up construction and reduction of manpower on site. This is how the actual Skylab looks like. In different elevation views. Some people actually mentioned that the surface don't look very good. So it depends on the owner's requirement. If you are willing to pay for more money, the supplier of the mass engineered timber can actually carry out some process to eliminate the surface defects and make the surface look very slick and homogeneous. But if you do not want to pay money, then you can get it as a raw, untreated look. Okay, again, this is a picture of the ceiling board. Okay, you see, ceiling board, lighting fixture. Right, this one is the external areas. Okay. Shangri-La Hotel Singapore also used mass engineered timber to create a pavilion that looks very interesting because of the shape. It's shaped like an onion, and the timber components needs to be bent in two different directions in order to achieve this particular shape. So the design is actually a three-dimensional design, and the timber component curve in two directions. So the GFA is only 49 meters square, yeah, But the benefits is that if you were to use concrete or steel, there is going to be more noise and dust generated compared to using these timber components. So there's a reduction of construction time by adopting off-site prefabrication of the Kulam cage structure here. HDB also adopted timber components for the construction of a RC center at the Bukit Batok. So again, a small area, yeah, but just to showcase the feasibility of using timber components. So for this project, they reported that the speed up construction and reduce manpower on site, generate less noise and dust. This is a bigger project. Okay, this one is at the Nanyang Technological University. They have constructed a sports hall, and they use the mass engineered timber to construct the roof as well as some other structural elements of the sports hall. So the GFA in this case is much bigger, 14,851 square meters. Yeah, the area where the mass engineered timber was used is around 9,775 meters square. The remaining areas is actually using combination of reinforced concrete, okay, for the ground foundations and a little bit of structural steel. So in terms of manpower savings, around 37%. Okay, benefits, okay, no temporary support needed for the arch roof construction. Timber roof structure provides 8 times better heat insulation than concrete. Speed up construction, reduce manpower on site. So in terms of the speed, okay, it took around 3.5 weeks to assemble the roof compared to using conventional methods for say RC or steel roof, which is going to be around 3 months. Also, it's 60 times more energy efficient and therefore it is more sustainable in that sense. This is a schematic of the roof. Yeah. So mainly they use mass engineered timber, but there will be some places where they use RC and structural steel, and that in a way also show you the versatility of the timber. It can be used in conjunction with other structural materials. This is how it looks like when it's completed. And here they show you one bay of the lifting of the sports roof. So they actually fabricate the components on site. Then after that, they use 2 cranes to lift both ends of the roof. Okay, to lift it up. Okay, 2 cranes. Okay, and once they lift it up, they join at the center, and you complete one bay, and they then move over to carry out the next bay. There are around 6 to 8 bays, okay, that make up the total roof. JTC also make use of the mass engineered timber to showcase the construction of a factory office block at this JTC launch pad at One North, the Block 81. So for this project at Block 81, they reported that the time taken to complete the project using mass engineered timber was faster, it was less disruptive, more efficient, but the thing to take note is that actually the timber components is much more expensive compared to concrete. So that is something that the project stakeholders will need to look at in terms of how to make use of the benefits to offset the more expensive cost of the material.